This is vlog 2, looking at skills and capacities in speed and agility. For the purpose of this vlog, we can think of skill as the technical performance of a specific movement in the most efficient way possible, and a capacity being the physical quality required to produce that desired movement. First off, we've got athlete A, who will be performing an A skip, and they have an underlying capacity issue of a limitation in left calf force production and rate of force development. So this is an athlete that has experience using this drill, and as we can see from front and side on views, has a technical capability to achieve some of the positions we're looking for. So firstly, from the front on view, we're going to look to highlight the positioning of the foot underneath the centre of mass of this athlete. So as we can see from the athlete's right leg, they're able to position the foot directly underneath the base of support. We can see the toe pointing forwards, directly positioned underneath the knee and the hip. So now as we look at the left leg, this is where the athlete starts to stray from this technical model. We can see the foot and ankle is positioned in slight plantar flexion and inversion at ground contact. We can highlight this by drawing a line straight down from the hip and knee. I believe this is a compensatory strategy adopted by the athlete due to a lack of rate of force development of the left ankle, thus allowing them more time to produce that force at the ankle joint. We can highlight this further in the side on view. Where we would like single limb support on the left leg, we actually see the athlete use the right leg on the floor to produce some of that force due to this lack of capacity at the left ankle and calf. If we compare this to the stance phase on the right leg, due to the greater ability to attenuate this vertical ground reaction force, we see the left leg is able to recover through with the ankle coming through at the height of the knee for the next step through. As we can see in this image here on the right side, at toe off, the athlete is able to produce a nice positive shin angle, allowing them to produce a more horizontally orientated force whilst the hip and knee extends. As we compare this to the left side, we can see at toe off, the ankle is positioned in much less plantar flexion and they have a weaker shin angle. This is due to a lack of force production of the plantar flexors and a reliance on the hip and knee extensors instead. The final phase of toe off, on the left side, we can again see the athlete inverting their ankle and rolling on the outside of the foot. I believe this is a strategy again to allow them more time to produce force at the plantar flexors. And comparing this to the right ankle, where we can see the athlete loading through the big toe, pushing into the ground and allowing the knee and hip to maintain a more extended position. On further assessment with this athlete, we were able to highlight that had a significant ankle injury previously and also had a 1 centimetre muscle girth deficit on that side. During some testing on force decks, we were able to highlight this athlete had a significant deficit, particularly pronounced on repeated hop tests and depth jumps, which are tests that are thought to particularly stress the plantar flexors. As we can see here by this chart, we can see the significant bias towards the right side during a depth jump, particularly on landing rate of force development. So in summary, we were able to highlight some abnormal kinematics that this athlete displayed, including excessive plantar flexion at ground contact, both feet being in contact with the ground during the skip, as well as a lack of a positive shin angle during toe off. So as discussed, I believe these abnormal kinematics were a compensatory result of a lack of calf force production and rate of force development. We were able to objectively display this to the athlete using the force decks, as well as monitor our response to training. So as a result of this, our interventions to address this should be strengthening the calf alongside plyometric drills such as pogo jumps and single leg depth jumps. We'll hope to address this deficit and assume it will improve the kinematics of the A skip. So next we're going to be looking at athlete B performing an A skip as well, and this is an athlete that doesn't have as much experience with this drill and maybe doesn't achieve some of the technical positions we'd like. As we can see from this position here, the athlete's gone into a position of adduction where the left leg's crossed over the body, where we would want them to be directing their movement forwards down the track. As a result of this, as we see them take their next step, the right foot also contacts the ground in a position of adduction with the toes pointing across the midline of the body. This is again due to a lack of coordination to maintain the movement directing forwards. When looking at the athlete's arm position, we can also see this excessive rotation where the athlete loses the arms by the side position. This reflects a failure to create the stiffness required to move efficiently during this drill. Again, we can see the athlete planting with the right foot and the toes pointing across the midline. This requires the athlete to take a little hop to the right in order to adjust his feet. From side on, we can identify the athlete's failure to aggressively switch legs and drive down into the ground to produce force. As we can see during the stance phase, the opposite leg lags behind, is slow to recover through, and recovers through low at around ankle height. We'd like to see the legs acting like pistons here with a quick aggressive switch, and the recovery leg recovering through quickly at around knee height. As we can see from this position here, the athlete actually adopts good front side mechanics with the hip flexing 90 degrees, the knee at 90 degrees, and the ankle dorsiflex with tension. Due to the lack of an aggressive switch here, the athlete actually loses a lot of energy from this position, and instead of striking down to the right and recovering the left leg quickly, ends up with the left foot trailing behind again. So in summary, we know this athlete is not experienced with these types of running drills. We've been able to highlight some technical faults such as excessive trunk rotation, poor arm swing, a crossing over with abduction at the hip, and a lack of drive into the ground and recovering the opposite leg. So for this athlete where coordination and technical performance drives their movement patterns, we can look to address this through technical coaching, video feedback and external cues. Drills such as A-skips with a stick overhead may also provide a constraint to allow the desired movement patterns to emerge. For this athlete, we can identify a capacity issue during this cut, as we can see a number of ways that they've tried to reduce the demand, particularly eccentrically, during the cut. We can see as the athlete approaches to cut, they start to decelerate early in order to reduce the eccentric demand and the requirement for rapid force attenuation and production. This can be highlighted by the heel strike into the ground with the foot in front of the base of support and a relatively extended knee. The athlete also adopts an upright trunk position, again to reduce muscular demand on particularly the knee extensors. The athlete also takes a number of small steps as they approach the cut, as we can see in these frozen images. This is again to reduce the requirement for rapid muscular force production. Finally, instead of taking a straight line into the cut, the athlete has actually increased the angle, so rather than performing a 180 degree cut, has turned and exits out, making this more of a 150 degree turn. This is a strategy again to reduce the muscular demand required to perform a 180 degree cut. Using poles as a constraint forces the athlete to execute a 180 degree cut. However, subjectively it reduces the speed of the turn, with the athlete finding it difficult to explode out from this position. So in summary, this athlete has adopted a number of compensatory strategies. These have been identified as having a high centre of mass on the approach to the cut, not entering and exiting from the cut at 180 degrees, and using choppy steps and an early deceleration. This athlete tends to score lower than matched individuals on strength scores as well as reactive strength indexes. So this strategy we see is likely a result of this poor force production and rate of force development. Addressing this may involve both using constraint-based approach, but also specifically looking at training eccentric muscular qualities and rate of force development. So for this athlete now, performing a 45 degree cut, and we'll be looking at where a technical issue interferes with the efficiency of the movement. We'll be focusing on the position of the stance leg as this athlete performs the cut. So as they plant on the left leg here to cut, we can see the positioning of the foot outside of the base of support. We can visualise this base of support by drawing this green line directly down towards the ground. We can see from highlighting the athlete's left ankle how wide this stance leg is as they try to push off. Positioning the foot outside of the base of support in this way is likely to be inefficient for force production. So we tried a few hurdle drills to encourage the athlete to land underneath their base of support and be able to drive through this stance leg. To summarise for this athlete, they display a technical issue during a 45 degree cut that doesn't allow for the most efficient movement pattern. This positioning of the stance leg outside of the centre of mass reduces the mechanical efficiency of this leg to produce force in the direction required. Drills such as the hurdle hop into acceleration that was shown could be used to encourage the athlete to position the foot closer to their base of support, allowing for a greater force production in the desired direction. As well as the specific cueing and coaching of the position of the stance leg during the task itself is important to ensure transfer to the 45 degree cut.